Okay, another common mistake on the test was the problem number 6, where the function h given a value t equals negative 16t squared plus 125t plus 3, which you were told shows the height ht in feet as a function of time t. So ht is the height, t is the time. And this is for in seconds for the flight of a model rocket. Interpret the function, use it to determine times when the model rocket was above 100 feet. Check with decimals. Well, the first thing you're shown is this equation. So what happened? HT, we're finding the height. That's what that is at a given time. That's what we're looking for. Okay. And then, why are these things in here? Negative 16, that's gravity. At per second per second. There's 2 t's by it. Well, second times second would be second squared. Gravity is pulling things down faster than they go up, unless your velocity would ever match what gravity is doing to pull it down. 125 is the velocity, and it's the initial velocity, the beginning of velocity. If the word initial doesn't make sense, like I ask you your initials, you're going to, for me, I'd say BK, Brian Clee. It rolls right out. And then lastly, the 3 would be the starting height or the initial height. Again, initial and beginning and starting, all the same, all very similar words, okay? And real briefly, just kind of checking things on decimals, a couple of those things should make a lot of sense. Right there is our 3 feet. We start up, we start at, we go up, we go back down, okay? And now what we're ultimately looking for is when does hx equals 100? Well, the answers are going to be very clear once we graph it. It's that point there of intersection at 0.874 seconds all the way to 6.939, so probably 6.94 seconds. The way you were asked to do that is, all right, how would we solve this with quadratic formula? Well, quadratic formula requires one side of the equation to equal 0, so the opposite of 100 would be minus 100. So if we simplify that sum now, we got negative 16 t squared plus 125t. And mental math or calculator, 3 minus 100, I will have a negative 97. So now it's set up Pythagorean theorem. There's A, there's B, and over here is C. So you had to choose the Pythagorean theorem that's set up correctly. Well, all of them were identical, except for one part. So we got negative B over 2A plus or minus B squared. Sorry. Minus 4AC. Again, all over 2A. So I'll show these values dropping in, and we'll go confirm this graphically. You didn't even have to truly evaluate this. So 125 is going here and here. That's the B. A is dropping in, is substituting in here, here, and here. And then 97, negative 97, don't lose the signs, is substituting in there. So that's what we had to look for. All the problems were identical, except for that value of C was what was changing. So be able to set up quadratic formula, be able to get the equation in standard quadratic form where one side equals 0. And then you potentially crunch that in your calculator, and or you'd go check it on decimals. And again, the times are from 0.874, so 0.87 hundredths of a second, to 6.946 and 94 hundredths of a second. The flight of the rocket would be above 100 feet. And if you're asked for the max height, it's right there, 247.14 feet at a time of about 3.913 and 91 hundredths of a second. So please recreate that problem again. What height are you trying to get to? Get it in standard quadratic form. Be able to write the quadratic formula. And lastly, be able to identify, again, either with quadratic formula or with a graph when the rocket was over a certain height. By the way, recreate wise, negative 16 is going to stay in it. This number, velocity, will change. Pick something a little bit bigger or smaller than 125. And the starting height, that should also change. Pick something different than 3 feet. I don't know, 2, 0, 1, 4, 5, whatever you would like to choose.